What's up, everyone? So today we're going to go over some of the fundamentals of Python programming. For each topic, we'll first discuss it on a conceptual level over here, and then we'll cover how the concept is realized when programming in Python over here. While we are still learning the fundamentals of Python, we are going to use this environment called Code Sculptor. This was developed by a few computer science professors at Rice University, and it's the coding environment used in all intro-level computer science courses at Rice, and some other universities as well. It provides a friendly environment for beginners and is also very convenient for instructors. For now, there are 4 things to know about this environment. The first is that it uses Python version 2.7. And the second thing is this play button over here. In order to actually compile and run the program you've written in this coding section, you need to click the play button. And then once you click that and it's run, the output that the program will create will print here, assuming there is output. And then third, notice that you can save what you've coded with using this button. This will create a new unique URL up here that you can then save somewhere like a Google Doc, and then you can use it to get back to whatever code you've written. This is honestly the main reason that it is so useful for teaching, because instead of sending around files and whatnot, you can just send a link to code. And lastly, over here, this button right here will take you to the Code Sculptor documentation. And once you click it, the documentation will open up over here, and this has a lot of documentation regarding Code Sculptor itself and what's supported, and then it also has documentation on Python in general. And it's really great documentation. I urge you to take a look at it anytime you're confused about something or simply you just want to learn more. And if this doesn't have something you're looking for, then you can really just use Google and you'll find a bunch of really helpful resources that will tell you what you need to know. So our first topic is functions. In programming, a function we thought of as just a type of procedure or routine that can be called and executed any number of times. For example, let's consider a very basic function f. And say this function takes an input x and will output x squared. Then if we were to call this function and give it as input 10, it would of course return 100. So the syntax for creating a function is always very specific to the programming language that you were using. So let's take a look at how you would make this function in Python. So in order to create a function in Python, we need to define it using the keyword def. And then we say the name of the function, and let's call this one compute squares. And we want to pass an input x, so the input will go here inside the parentheses. And there, that's our declaration. So in Python, it's considered good practice to separate words using underscore like this. Also, when you name it, you want to use a name that is relevant to what the program does. You could call it whatever you want, and you can call the input whatever you want, but it's helpful to be clear. So, and then once we have defined the function, the body of it goes inside here. And for this function, all we wanted to do is return the square of the input. So what we can say is just return x squared. And so these double asterisks is how you create exponents in Python. And so now, if we want to call the function, we can print it, so the return value will print. And then we can call it on a few different inputs. Let's call it on 10. Let's call it on 2. And let's call it on 5. So now if we run the program, we get the output we expect. So for the square of 10 is of course 100, square of 2 is 4, and square of 5 is 25. So it works exactly as we expect. Great, so this is an example of how to make a very basic function in Python. Let's move on. So our next topic is expressions. And in programming, expressions follow pretty much the same rules as the arithmetic expressions you learned in your math classes. So you have things like x plus y, x divided by y, x times y, and so on. And so really, we can just think of an expression as even in a programming language as any combination of one or more explicit values, constants, variables, operators, or functions. And then the programming language then interprets and uses this expression to compute some value. So let's take a look at how an expression would be realized in Python. So suppose we want another function called, or that takes 2 inputs, let's say x and y, and computes the sum. So then we can call it compute sum, and we'll pass it x and y as inputs. And so we've defined it. And now what we want to return is just simply the sum of the 2 inputs, like so. And now we don't want to see this anymore, so we can comment it out. And you can say that by highlighting all and hitting Apple and just adding a hashtag like so. And that's how you create, like, now the program knows that this is just comments and doesn't actually do anything with it, and it's just for the programmer who's made it. So now if we want to call this function, our new function, on some inputs, let's say like 10 and 1, say 3, 2, and then we'll just pass it some negative numbers too. We'll say negative 2 and 5. So now we can see what this will do and how it handles the expression. And of course, it does exactly what we'd expect. So it just adds the two inputs together and prints the output, or returns the output. Cool. So that's how you make an expression in Python. And we'll see some more interesting expressions as we move forward this video, and of course as we move forward in the subsequent videos. But for now, let's just move on to our next topic, which is variables. So in programming, we can think of a variable as just being a means of creating reserved memory locations to store values, and which we then will use an identifier or a variable name to reference the value and access the location in memory. So before we see how this works exactly in Python, I want to first introduce our final topic of types, and then we'll see how these two concepts together are realized in Python. So in programming, we have a variety of different data types, and different data types can be used in very different ways for a number of different purposes. So in a way, we can just think of a type as being a classification of data which has its own respective properties and methods that can be applied to it. So today we're going to go over just 5 different types, and that's integers, floats, Booleans, strings, and null. So any given variable that we define will reference a value that has a specified data type. And so let's see how this would happen in Python. So if I want to just, or in these two functions, they're accepting an integer here and using those. And we can very easily confirm that it is of type integer using a built-in Python method called type. And so you can pass type any variable or any value you want in order to see what data type it is. So now when we print this, we'll see that each of these inputs are of type int, meaning integer. But what if we want to use inputs that have decimals? Well, in Python, decimals are represented by what we call floating point numbers. And these will have the type of float. So let's make some of these inputs decimals and see what happens. And so now when we run it, we can see the ones that have a decimal are considered type float, or a floating point number. And then the return value, when an expression is given a floating point number, it will return a float as well, even if one of the other values in the expression is an integer. So let's there's another important property we need to go over regarding how integers are handled in Python. So let's say we have a function called compute quotient, and we again give it two inputs, x and y. And what we return is just the first input divided by the second. So now, if we want to call this on some inputs, let's give it 4 and 2, and then let's give it 3 and 2, and maybe 15 and 4. So now if we could run this, and we'll once again comment these out using the hashtag. And now so we can just focus on these ones. So now our output is probably not what you expect. I mean, for the first one, it seems to work. 4 divided by 2 is 2. But 3 divided by 2 in our classical understanding of math is not 1. And 15 divided by 4 is not 3. So the issue here is that in Python, there are rules governing integer arithmetic. And any expression that is given only integers will necessarily compute and return an integer. So 3 divided by 2, when there are integers, instead of returning the exact value of 1.5, they will return the floored integer value of it, which is simply 1. And of course, that is what we get. In order to actually compute the exact value of 3 divided by 2, we need to use floats, which the type that we just discussed. So there are a couple ways that we could do this. Option 1 is simply just to pass the function floating point numbers, and it will give us exactly what we want. So now we see that the output is 1.5. But let's say we know that this function that we have defined is going to accept only integers, and we still want it to compute the exact value. So what we can do is we can cast the numerator to a float, and even if x is an integer, it will be converted into a float. And now when we output it, and so we can put these back to integers, and let's see what happens. And now all the return values are floating point numbers, and they're exact. Also, another way you can do this is just to say multiply it by a floating point number, and the exact same thing will happen. So the output does not change. And it is only necessary that when computing division or any sort of expression, only one of the numbers needs to be a float in order for the expression to return a float. All right, so that's enough about floats and integers, and let's go on to the next one. So the next one is Booleans. A Boolean data type can take the form of the two truth values we use in logic, which are, of course, just true and false. So let's see how you can use these in Python. So let's just make some very basic functions called def print true, and we don't need these to accept any inputs. And then we'll just say return true, and then print false, and we'll just return false. And so it's actually necessary in Python to capitalize these, because if you get rid of the capital, it is not anything that Python will recognize, and will throw an error saying unknown variable. But the capital is true and false, so the Boolean data type. And we can even print the type of true and print type of false. Sorry. And now if we just print false, or print true and print false, we get type bool, as we would expect for the Boolean type, and then true and false. So great. So those are just the basic idea of Booleans in Python. In the next video, we'll learn about conditional logic, and that's a way you can use Booleans to create more complicated and interesting functions in Python, where the function will only do some things based on one condition and other things based on another, regarding truth and false. But for now, let's just move on to our next data type of strings. So in Python, or in general in computer programming, we can think of strings as a sequence of characters that we use to create text. And so if I wanted to create a variable over here, let's call it name, and I can set it equal to Eli, which is my name, and then I print name, and our output will get Eli. And then we can comment out these because we don't need them anymore. And strings can include any kind of characters you want in any kind of combination. So if I just want to create nonsense and set it equal to just a bunch of nonsense, like so, and then if I print nonsense, we'll still get that text. Great, so it does exactly as we expect. Now, suppose I want to make a function that, given a first name and a last name, will print the full name. So let's call it print full name, and we'll give it first name, which we'll call f name, and last name, which we'll call l name. And then in here, we can define a local variable called full name, and set it equal to f name plus l name. And here, it's important to understand that this addition is not actually adding it together in the way that integers or floating point numbers would be added. Rather, because they're strings, the program will just know to concatenate or combine these. And then so when we return full name, we should get the full name. And we'll give it Eli, and my last name. And then we can run this, and we get my last name. But see, the issue here is this isn't very readable. And that's because the two strings of first name and last name are just being combined directly. So instead, in the middle, we can concatenate a space so that it will print out a readable version of the full name, like so. And also, just to understand how these adding operators are not really adding in the same way that it would for integers, if we throw together 2 plus 2, if they're integers, it would be 4, but here it will just be 22 because it just combines the two strings, as we explained. So yeah, so that there are like a lot of things you can do with strings. They're very powerful. They're used in a variety of different ways in programming. But for now, this is all we're going to cover for them. In the subsequent videos, we'll learn a lot more about them. But the last type that we're going to go over is null. So generally speaking, in computer programming, a null object is just an object with no reference value, or with defined neutral behavior. Sorry about my typos. And then in most language, that object is simply referenced using just null, as you might expect. But in Python, it's a little different, and you have to use what's called none. And as you would probably think, this none has the none type. So then if I want to create a function to understand this, or I can first I can just say print none, and it will understand that that is none. This is a keyed variable. And then similarly, if I can print type none, I will get the none type, as we would expect. And this null object, or in Python, the none, is used for a variety of different things, but one of its main purposes is to serve as a placeholder for functions where where there is no return value. So if I can make a function called no return and just say return, give it no value, and then print no return, and then run this, see it actually returns none because there is no return value here, and that's how that's handled with this placeholder. All right, so that's all we need to know about null for now, and those are all the types we're going to cover. There's one last thing that we need to go over before we end this video, and that is a variable scope. So we've seen a little bit of this so far, but to understand it more concretely, there are, depending on where a variable is defined, it will have a different scope. So a variable can either be of global scope, or a global variable, or it can be local. So a global variable is a variable declared in the main body of the code outside all functions. And we have an example of this already. See, this name, Eli, is actually a global variable because it's not inside a function, it's in the main body of the program. And a local variable is one that's a variable declared inside the body of a function or block. And so we have an example of this as well. So here in the print full name, as I think I mentioned during the video actually, that this is a local variable. And there's different behavior regarding global versus local variables. So global variables can be accessed by any part of the program that occurs after its declaration. So to give an example of that, if I make a function, and so let's comment out some of these so we don't have our output filled up with nonsense. So now if I make a new function called def no input, I can still return name because this is a global variable and it has the scope to be accessed by anything any function declared after it or called after it's been declared. So now if I hit, So now when I print name inside of this function, so now it will be the value of that variable, which is Eli. But if I wanted to try and print full name, which is a local variable inside of this scope, it will throw an error because full name has not been defined in this scope. So that's kind of how local and global variables work. Another thing about local variables, though, is that if you want to, inside of a function, declare a variable name that is already used in a global setting, and let's say this one is Simon, when I call no input now, this local variable will actually override the value of this global variable, despite them having the same variable name. And we can see this by, if I write in here, see Simon is printed out because the local variable takes precedence. All right, so that's all we're going to talk about global and local variables. And that's really everything we're going to cover in this video. In the next video, we'll be learning about conditional logic and modular arithmetic. I'm going to now save this program over here, and this will return, like I said, a unique URL. And I'm going to save this over here in my Google document, and I'll post this in the description of the video, so that if you want to reference the code and play around with it. And then that's everything. So thanks for watching, and feel free to leave any questions, comments, or concerns in the comment section below. And I look forward to the next video.